Alright, in this video I'm going to be going over section 1, functions day 2. Specifically, our main focus is going to be finding domains algebraically. So for the most part, this is straightforward as long as you know your functions. So a quadratic function, if you see a quadratic, you know the domain is going to go from negative infinity to positive infinity, or an absolute value function will go from negative infinity to positive infinity. You learned a bunch last year in Algebra 2, and we expect you to remember them. First of all, we need to remember the definition of domain. So a domain is all possible x values of a function or equation, and we write it in interval notation. Which we've been talking about already. Okay. So if you remember back in Algebra 2, there are certain functions that have restricted domains. So one of those functions you learned about is rational functions. If you forget, a rational function looks like this. This is the parent, 1 over x. So it's when you have a fraction with x in the denominator. So because this has a restricted domain, if you remember, this is when the graph goes in opposite directions and has asymptotes. So we have to figure out, okay, how do we do this algebraically? So it's actually quite simple. Where is it undefined? Well, anytime the denominator is 0, the function will be undefined. Therefore, there'll be an asymptote. So keeping that in mind, we can't divide by 0. Like I just said, because it will be undefined. So that's going to give us the restrictions. So to do this, we set the denominator equal to 0, or not equal to 0 if you want, because it can't equal 0, and solve for x. These values can't be in the domain. Okay, so let's do an example. So determine the domain of, or algebraically, determine the domain of f of x equals 5x plus 2 over x squared plus 7x plus 12. So, as we just took notes on, we need to set the denominator equal to 0, not equal to 0. So we know that this is a rational function. So I'm going to take the denominator, okay, which can't equal 0, and we're going to solve as if it does equal 0. So we can, this is a quadratic, we can factor it. So what multiplies to 12 and adds to 7? Hopefully you're thinking 4 and 3, and if you're not, you might want to practice some of your factoring. Now we can use the zero product property. So x plus 4 can't equal 0, x plus 3 can't equal 0. So we know that x is not equal to negative 4, x can't be negative 4, and x can't be negative 3. So this is what can't be in the domain. So that means our domain is going to go from negative infinity to the next lowest, which is negative 4, and from negative 4 to negative 3, and from negative 3 to infinity. And you could double check this using a graphing calculator if you wanted to. Okay, so there's one more function we're going to talk about today, how to algebraically find the domain. See if you remember it. It is the radical function. I almost said rational again. We already did that. Okay, so radical function is square root. So f of x equals the square root of x is the parent. And if you remember, this is where it has an endpoint and then goes in a direction. So we need to avoid imaginary numbers to graph on a real number line. Right? This can't be negative or else we have an imaginary number. So we need to avoid imaginary numbers to graph on a real number line. So to do that, we know that this has to be bigger than or equal to 0 because the square root of 0 is 0 and square root of 1 is 1, and we can keep going, and they're real numbers. And if it's negative, then it's not real, it's imaginary. So all we do is set the denominator, the number under the radical, which is the radicand if you forgot, greater than or equal to 0. Now I'm going to give you a little challenge problem. So it is almost always greater than or equal to 0. The one time it's not is here. So determine the domain of g of x equals 4 over the square root of x minus 3. So because it's a radical, we're supposed to set it greater than or equal to 0. But this is also a rational function, and the denominator can't be 0. So what we do here is we take the square root, or we take this x minus 3 and we just make it greater than 0 because it can't equal. So then x is greater than positive 3 is our answer. So we know the domain is 3 to infinity. With a soft bracket because this is not equal to. So that's it. Now be careful because it's not usually greater than, it's only when it's a radical and rational. So little combo.